Hi everyone, and welcome back to Maths and Physics with Simons. Today's sequence and series lesson for grade 12s. Now we're going to learn how to write linear sequence, quadratic sequence, and geometric sequence in sigma notation, where we're going to use the sum sum and simplify how we solve sum. So sigma and sum actually goes hand in hand. All right. So writing the following in sigma notation. Number one, we have a linear pattern. So there we have 2 plus 5 plus 8 plus 11 plus 14. If I say 5 minus 2, I get 3. 8 minus 5 gives me 3. 11 minus 8, 3, etc. So it has a common difference. Therefore, I know it's a linear pattern. So my A value there is 2. D, 5 minus 2, which gives me 3. Right, so to write in sigma notation, I first need a general term of the sequence, right? So using Tn equal A plus n minus 1 times D, because it's a linear pattern. A is 2, D is 3. 3 times n gives me 3n, 3 times minus 1 would give me negative 3. Negative 3 plus the 2 for A gives me negative 1, so my equation Tn equal 3n minus 1. Right, so you see there's my 3n minus 1. My summutation sign, it has a starting point and an ending point. Right, so there 2 is the first term, so I'm starting by 1, n equal 1. And I'm continuing 1, 2, 3, 4, 5. So I have 5 terms. So I start by 1 and I end by 5. Alright, so n equal to 1. 5, I can write it below and on top. Yeah, I've just typed it on the side. Right, and if you want to test, if you see they have 1, 2, 3, 4, 5 terms, let's say 5 minus 1 gives me 4. But as you can see, I don't have 4 terms, I have 5. So always I say top minus bottom plus 1. So 5 minus 1 gives me 4. 4 plus 1 would give me 5. Right? So that is for linear pattern. Right, write the following in sigmatation. Now we have a quadratic pattern given. 1 plus 4 plus 9 plus 16. And they say 235 terms, right? So again, for quadratic pattern, I first need to find the general term before I can write in sigma notation, right? 4 minus 1 gives me 3. 9 minus 4 gives me 5. 16 minus 9 gives me 7. 5 minus 3, 2. 7 minus 5, 2. Very important, I subtract right from left, not left from right. Go right minus left, right minus left. Same there. Right, so solving, should remember 2a equal 2, 3a plus b equal 3, a plus b plus c equal 1. If you forgot it, you can go to the previous lesson on quadratic number patterns and learn how to find the formula for it. So 2a equal 2. To get a on its own, I have to divide by whatever coefficient is in front of a. So there 2a divided by 2 would give me 1a. 2 divided by 2 would then give me 1. Then I have 3a plus b equal 3. But a equal 1, so 3 times 1 plus b equal 3. If I take 3 over, it becomes 3 minus 3, which gives me b equal to 0. All right. Now I have a equal 1 and I have b equal to 0. So a there is 1, b is 0. A plus b plus c equal 1. All right. That's the formula for term 1. So 1 plus 0 plus c equal 1. If I take 1 over, 1 minus 1 becomes 0. So c equals 0. So 1 mark for a, 1 for b, 1 for c normally. So in my formula here is simply Tn equal n squared, which would have been the fourth mark, but here we're testing sigma notation. So 1 mark for the equation. If we write it now in sigma, we have the summutation sign. I'm starting by term 1 and I'm ending by 35 terms. So there, 35 minus 1 plus 1 would give me 35 n squared, right? Right, now let's go further. Writing the following in sigma notation. Now we have a geometric sequence, which is given as 64 plus 32 plus 16 plus 8. A being 64. R, term 2 divided by term 1. So 32 divided by 64, which gives me 1 over 2. So remember Tn equal AR n minus 1. So A being 64, they half n minus 1. So there's my formula. Right, I'm starting by term 1, n equal 1, and I have 1, 2, 3, 4 terms, right? So 4 terms, so therefore it ends by 4, n equal 1 up to 4 terms. All right, let's look at another problem. Write the following in sigma notation. So we have what we call triangular numbers, or the sum of n natural numbers. So I have 1 plus 3 plus 6 plus 10 given. Right, 3 minus 1 gives me 2, 6 minus 3 gives me 3, 10 minus 6 gives me 4. So it will continue being 2, 3, 4, 5, 6, 7, 8 going on. So that's why we say sum of n natural numbers, right? Triangular numbers. If I say 3 minus 2, 1, 4 minus 3, 1. All right, so 2a equal to 1, a equal to 1 divided by 2, which gives me half. Then I have 3a plus b equal 2, right? So the a equal half, 3 times 1 over 2 plus b equal 2. If I take that over, that's 3 over 2. If I take it that side, 2 minus 3 over 2, b equal to half. If I say a plus b, half plus half, would give me 1. If I take it over, equal to 1. So 1 minus 1 would give me c equal to 0. So Tn equal half n squared plus half n squared. Right, if we remove the common factor of half n, then the equation yields n plus 1 divided by 2. Right, and generally that is the formula for sum of n natural numbers. But yes, sigma notation, we're starting from term 1 and we're ending by term 4. So n equal to 1 up to 4, n plus 1 divided by 2. Alright, so that's the formula for sum of natural numbers. 1 plus 2 plus 3, etc. would be in that format. Alright, so hope you understand. This was just to make sure you understand how to write something in sigma notation. Alright, the fact that you've watched the next 4 videos, I'm proud of you. Means you are prepared to put in the effort. Remember, with effort comes hard work, and with hard work comes success. Alright, nobody has become successful doing nothing. Do not for one moment think that you're going to get success by not working hard. Right, you work hard and when you become successful, everybody like, ooh, that person lives soft. No, you did hard work to get there. And I'm proud that you are prepared to work hard to become successful, right? God bless. Bye.